Guys, welcome to another video. In today's tutorial, we have an exponential equation to solve, something very unique and challenging. So let's go see the problem and go through the solution together. So we have this nice, nasty looking exponential equation here. The square root of 3 to the 2x plus 1 equal to the cube root of 108 minus 3 to the s plus 7 upon 2. So s plus 7 upon 2 is actually the exponent of 3, so don't confuse that. So what I'm going to do to reduce the complexity, I am going to take each radical and simplify it before merging both the left-hand side and the right-hand side together. From the left-hand side, we have the square root of 3 to the 2x plus 1. If I remove the radical sign here, I will write this to be 3 to the 2x plus 1 raised to the power of half. Then I know that a to the power of half is same thing as the square root of a from the laws of exponents. Again, I will need to also go check out the product rule of exponents. If I have a to the x multiply a to the y, this is a to the s plus y. So I can actually, devolve this by splitting it into x and y, more like a reversible reaction. So 3 to the 2x plus 1, I can use the product rule to split the exponent into 2. So that's going to give us 3 to the power of 2s multiply 3 to the power of 1, all raised to the power of half. Okay, I need to try and minimize space. Then, having done this, the product power rule is another corollary to the product rule. So if I have a multiply b all to the x, I can distribute the power x between a and b. That becomes a to the x multiply b to the x. So if I use that here, I'm going to be having 3 to the power of 2x multiply half, because a power raised to another power will multiply the powers, then multiply 3 to the power of 1 times half. So you can see that the 2 here will cancel out 2. We are left with 3 to the x there. That will be 3 to the x multiply 3 to the power of half. Now, 3 to the power of half is same thing as root 3. So this will be root 3 multiply 3 to the x. So we've refined the left-hand side. Then we'll go to the right. On the right-hand side, we have a cube root there. Then we have 108 minus 3 to the power of s plus 7 upon 2. Again, I will use the product rule to split this. So this exponent, 3 to the power of s plus 7 upon 2. That will become, okay. Now, I'm going to be having cube root 108 minus 3 to the x multiply, 3 to the 7 upon 2. Okay, to write this very well. This board is quite small. 3 to the 7 upon 2. So it's better like this. Now, 3 to the 7 upon 2, or 3 raised to the power of 7 upon 2, we can actually say 3 to the power of 7 upon 2 is the same thing as 3 to the power of 3 plus half. Then again, I will also use the product rule to split this. This is going to be 3 to the power of 3 multiply 3 to the power of half. And we know that 3 to the power of half is square root of 3. Sorry for the slip, not cube, square root of 3. I'm a bit overexcited. Then I can then write this radical to be cube root 108 minus, 3 to the x multiply 3 cube multiply 3 to the power of half. Now, 3 raised to the power of 3 is 27. So I can then write it to be the cube root of 108 minus 3 cubed is 27. 3 to the power of half is square root of 3, or rad 3. I'll write this to be 27 rad 3 multiply 3 to the x. So with this distinct, expression on the right, I can then merge the left and the right hand side together. So we are now going to be having the square root of 3 multiply 3 to the x is actually equal to the cube root of 108 minus 27 rad 3 multiply 3 to the x. So before we do anything to remove this cube root, I will say let k equals 3 to the x. I can then write this to be the square root of 3k multiply k is equal to the cube root of 108 minus 27 rad 3 multiply k. So now I will then take the cube on both sides. I like the flow and the systematic approach. So on the left side, we are going to be having 3 cube. No, that's wrong. We are going to be having rad 3 cube. Rad 3 cube. So that's rad 3 multiply rad 3 multiply rad 3. Rad 3 multiply rad 3, that's 3. So we are going to be having 3 rad 3. Then k cube. Okay, here, this cube root, we undo the cube here, the radical sign will disappear. We'll be having 108 minus 27 rad 3k. Okay, it's actually a depressed cubic equation. So I will rearrange this. This is 3 rad 3k cube plus 27 rad 3k. No. Before we rearrange, let me divide both sides by 3 rad 3. Okay, let me still do it this way. That will be minus 108, everything equal to 0. No harm, no foul. Okay, I'll divide 2 by 3 rad 3, 3 rad 3, 3 rad 3, 3 rad 3. So 3 rad 3, we leave the system, we have k cube. 3 divide 27, okay, that's 9. Rad 3 will cancel out, we have plus 9k. Here, 3 divide 108, that's 36. 36 over rad 3, that will be 36 rad 3 upon 3. Okay, that will be 12 rad 3. 12 rad 3 equal to 0. So, this is actually a depressed cubic polynomial. Now, because of the radical sign here, we cannot use the rational root theorem. So, but we are going to second guess, more like an educated guess. So if we say k equal to rad 3, which implies that k minus rad 3 equal to 0, we can actually test whether k minus rad 3 is a factor of this depressed cubic equation by sticking k equal to rad 3 here. Then before we now test whether the remainder is 0 from the factor theorem. So if I substitute k here, that will be rad 3 cube. 9 multiply rad 3, that will be 9 rad 3 minus 12 rad 3. We are going to check whether these 3 guys will give us 0. Rad 3 cube is 3 rad 3. Okay, it's going to work. Plus 9 rad 3 minus 12 rad 3. Okay, 3 rad 3 plus 9 rad 3, that's 12 rad 3. It's going to be 12 rad 3 minus 12 rad 3, and this is actually going to give us 0. So we can then say that k minus rad 3 is a factor. Then I will then go and use the long division. That's actually the most suitable for this division. I'm going to use a long division for polynomial, something I seldom do because of syntactic division and factorization. So we have k minus ra3. I will draw the division sign, or rather the long division sign. Should I take this down? Okay, let me bring this down a bit. So we have k minus ra3. Okay, then we have k cubed plus 9k minus 12 ra3. Okay, it's customary that we use k to divide k cubed. That would be k squared. I'll write k squared here. K squared multiply k, that would be k cubed. K squared multiply ra3, that would be negative ra3 k squared. Okay, we subtract. So here, k cubed, we undo each other. We have 0 there. And we are going to be having 9k minus ra3k, plus ra3k squared minus 12 ra3. This is the reason why I seldom use this. So here, the coefficient of k squared here is actually 0. No, not the coefficient. Okay, it's 0 coefficient, 0. 0 minus ra3k squared will give us plus. So I can actually say, okay, this is the highest power here. K divided ra3k squared. That will be ra3k. This is the only trickery part of this problem. Then I think I should write this symmetrically. This will be ra3k squared plus 9k minus 12 ra3. So k divided ra3k squared. We have ra3k multiply k. That will be ra3k squared. Here we have ra3k multiply ra3. Ra3k multiply ra3. Ra3 multiply ra3, that will be 3. So we are going to be having 3k. So here we are going to be having minus 3k. Okay, I will subtract again. We are going to be having these guys leaving the system. 9 minus 3, that will be 12. So you have 12k minus 12 ra3. So k divide 12k, that will give us 12. So we now have 12k minus 12 ra3. So the remainder is actually 0. It means that k minus ra3 is a factor. Okay, our factors now are actually, so therefore this implies that k minus ra3, since the remainder is 0, k squared plus ra3k plus 12 are the factors of this polynomial. Now, I already know this answer. This is actually equal to ra3, k is equal to ra3. Here, I need to test whether this quadratics is going to give me a real root or an imaginary root. So it means that I have to use the discriminant. So b squared minus 4ac, if it is greater than or equal to 0, we know that these quadratics have a real root. But if it is less than, it means that it has imaginary roots. So b is ra3 squared, that's 3. Then 4 multiply 1 multiply 12, that will be 48. Okay, this one will be negative 45. So guys, it means that k squared plus ra3k plus 12 does not have real roots. It means that we have complex solutions there. So we are going to reject this. So we reject the quadratics. So we are the very last lap now. If we reject the quadratics, we are only left with just one option. That is k minus ra3 equal to 0, which implies that k equal to ra3. And at the very beginning, midway, we used a substitution that k equal to 3 to the x. So it implies that when k is ra3, we have 3 to the x equal to ra3. So if I remove the radical sign, I will write 3 in exponent form. 3 to the x, that will be 3 to the half. The bases are the same. So S is equal to half is the solution. So we need to test this. And we need to recall the main problem. The square root of 3 to the 2x plus 1 equal to the cube root of 108 minus 3 to the s plus 7 over 2. So we are almost done. Then to check or fast check, I just want to satisfy curiosity that s equal to half is the true solution. So if I stick in half here, we'll be having the square root of 3, 2 times half plus 1. Okay. Is it equal to the cube root of 108 minus 3 raised to half plus 7 over 2? We cannot tell because we are not Einstein, neither are we Stefan Wolfram. So 2 times half, that's 1. So we'll be having the square root of 3 squared. So here we'll be having cube root 108. On the exponent here, we have half plus 7 upon 2. So that will be 8 over 2, which is 4. So 3 to the 4th. So the question is this. 3 raised to the power of 4, that should be 81. Okay? Will the square root of 3 squared be equal to the cube root of 108 minus 81? Okay, indeed, this is true. This is true. It's actually 3. Now we have the cube root of, 27. And the cube root of 27 is actually the same thing as 3. Since the left-hand side is equal to the right-hand side, it means that our solution is perfect. So guys, we've come to the end of another interesting tutorial. If you derive value and you want to encourage us by joining this community, please do well to subscribe and don't forget to turn on the post notification so that you can be notified anytime I upload a new video. Give this video a like, share it to your friends and colleagues. See you next time. Bye.